Okay, so now we move in the portion of how we apply what we just learned for quadratic inequalities into what you have learned previously in your discriminant portion. Okay, so just a quick recap. Okay, when you have two real and distinct roots, okay, that means your curve intersect the x-axis at 2 points. Okay, your b squared minus 4ac is more than 0. Okay, two real and equal roots, okay, which means I only have one solution, equals to 0. No real roots, okay, where I have no solutions at all, does not intersect. Okay, your b squared minus 4ac is less than 0. Okay, so previously I went through with you this portion as well. Okay, the keywords to take note. Okay, your b squared minus 4ac less than 0. Okay, especially this portion here where it's always positive or always negative. Okay, always positive means it will lie in the positive y region. Always negative means it will lie in the negative y region. Okay, so b squared minus 4ac is less than 0. Okay, all these touches tangent at one point, repeated root, one solution equals to 0. Okay, intersect at 2 points or two real and distinct roots. This is what I mentioned earlier. B squared minus 4ac more than 0. Okay, the part where a lot of students miss out. Okay, this last portion here. When they say intersect, but they never say how many points. Okay, it could be 1 point, it could be 2 points. Okay, so we won't know. So just assume it to be more than or equals to 0 because it could be either scenario. Same thing if they say real roots. Okay, it could be real and repeated or real and distinct. So I have both scenarios as well. Okay, line meets the curve, same thing. Never mention 1 or 2 points. Okay, so just assume both scenarios. Okay. Next. Okay, if you have one line and one curve, okay, always use simultaneous equation. Okay, but when you see any other letters, okay, p square, m square, k square, or x square, okay, we're gonna use our quadratic inequalities. Okay, so what do I mean by that? Let's take a look at an example behind. Okay, let's just take a look at 5a together. Okay, find the range of values for p. Okay, so this is no longer x or y. Which the equation x squared minus px plus p equals to 0 has two distinct roots or two distinct real roots. So if I have two real and distinct roots, which means my b squared minus 4ac should be more than 0. Okay, so part A, same thing. Identify your A, B, and C. Your A is 1, B is minus P, your C is P. Okay, B squared minus 4AC we established earlier, more than 0. So sub in your terms. Okay, you have minus P squared minus 4 times 1 times P, more than 0. Okay, and I have P squared minus 4P, more than 0. Okay, then what a lot of the students might end up doing here, okay, it's very easy. Just divide by P. Okay, which what I'm trying to say is some of y'all might do this. Divide by P on both sides and then you solve for P like that. This is wrong. Okay, you cannot divide a P like that. When you do that, you are essentially removing or eliminating one solution. Okay, the correct way of doing this is to factorize out P from both terms. Okay, so P times P minus 4 more than 0. Okay, then from there you apply what we learned earlier. Okay, draw out plus minus plus. Okay, positive P square, right? That's why it's a smiley face. Always make it positive. Okay, so you are interested in the positive region. So circle the 2 plus. Okay, what are your two roots? 0 and 4. So therefore your solution is P less than 0 or P more than 4. Okay, that's it. Okay, so try out the rest of the examples on your own. Okay, now let's take a look at this next portion here. Always positive and always negative, which means your graph, they are saying your graph is always positive or always negative. So if I were to represent this on a graph, okay, when it's always positive, b squared minus 4ac is less than 0, right? Based on what we discussed earlier. And a is more than 0, where it's a smiley face. So if I were to represent this on a graph, this is how it will look like. Okay, a smiley face floating above the x-axis, which is the positive, always positive. Always negative, take note, okay, your b squared minus 4ac is also less than 0. But in this case, your a is less than 0, which means it will be a sad face. Okay, now you may ask, why can't, for the always positive, why can't it be like that? Why can't it be a set face? Okay, so because if it's a set face, if I were to extend the graph, ultimately it's still gonna hit your x-axis. That's why this portion here is very important. Okay, when it's always positive, the A must be more than 0. Same thing, if it's always negative, why must it be a set face? Because if I were to draw a smiley face, okay, if I extend this upwards, it's gonna cut my x-axis again. Okay, so these two conditions are very important. Okay, so let's take a look at an example to have a better understanding of this. Okay, so an example question. Okay, find the range of k for which this is more than 0. Okay, so more than 0 means what? If I write more than 0 here, it means it's always positive. So apply what we just learned. Your b squared minus 4ac must be less than 0 and a must be more than 0. So let's put these two conditions into practice. So b squared minus 4ac less than 0, sub in your a, b and c. Okay, when you solve for k, you'll get k less than 5 over 4. Condition 2, a is more than 0, right? So k minus 1 more than 0, k more than 1. So now you need to combine both inequalities to see what is the final inequality for the range of k that satisfies what you want. Okay, so if we were to draw a number line, okay, this is 1. Okay, let's draw out k more than 1. So towards the right, okay, I'll label this k more than 1. Okay, 5 over 4 is bigger than 1 because it's 1/4. Okay, less than. Same thing, there's no equal signs for both, so it's a hollow circle. Okay, this is k less than 1/4. So the region that satisfies both of these inequalities, okay, is this region here that I've shaded. Which means your k has to be more than 1 but less than 1/4. Okay, so always apply these two conditions when you have such a scenario. Okay, the last portion here, okay, to show that discriminant is more than 0 or discriminant is less than 0. Okay, so to prove that b squared minus 4ac is less than 0, we always use completing the square. If your discriminant is quadratic, okay, it means it's power 2. So for example, show x squared minus m minus 12 bracket x minus 3m has real roots. So these real roots could be real and distinct or real and equal. Okay, that's why I have two scenarios here, more than or equals to 0. Okay, so equate your b squared minus 4ac, sub in the values. Okay, when you expand and simplify, you'll get m squared minus 12m plus 144. Okay, but there's no way I can show that this is more than 0. Okay, so you have to do completing the square, and after you have completed the square, you will get this form here of m minus 6 bracket square plus 108. So if you remember, whenever I square any value, be it positive or negative, it will always be more than or equals to 0. So since m minus 6 bracket square is more than or equals to 0, I plus a positive value at the back, it has to be more than 0. Therefore, b squared minus 4ac is more than 0, and I can say the equation has real roots. Okay, so this is an example of how we apply or show that discriminant is more than 0 or less than 0. Okay, now let's take a look at an example, okay, to demonstrate what we have just talked about. Okay, so in an algebraic fraction with inequality, you only need to either prove the numerator or denominator is greater or smaller than 0. Okay, so what do I mean by this? Let's take a look at this example. Okay, so show that x squared minus 2x plus 5 is always positive, which means they are asking you to show that x squared minus 2x plus 5 is more than 0. So if this expression here is more than 0, that means always positive. You can say that your b squared minus 4ac is less than 0. So this is what you need to use to prove. Okay, and then always positive means what? Your a must be more than 0, right? Which in this case it is because it's positive 1. Okay, so work out what is b squared minus 4ac. you have a negative value, okay, less than 0. First portion done, okay, which is this b squared minus 4ac less than 0. Then since the coefficient of x squared is 1, okay, your a is more than 0. Both conditions are satisfied. Okay, so you have x squared equals to 1, b squared minus 4 is less than 0. Therefore, x squared minus 2x plus 5 is always positive. Next portion. Hence, find the range of k for which this inequality holds. Okay, so let's take a look at the next page. Okay, so essentially, how did I get into this step is all we did was to bring over the 1. Okay, so you might ask, why I cannot cross multiply in inequalities? Okay, which means why can't I just, if this was the original equation, which is in the previous page, why can't I just multiply over to become like that? Okay, the reason is because I do not know whether this denominator is positive or negative. Although yes, okay, we have proved that it is always positive in this scenario. But if in questions, okay, we don't have this portion here, okay, we cannot just cross multiply like that, because who knows, it might be a negative number and I might have to flip the sign. Okay, so never ever cross multiply in inequalities. Okay, just bring over the minus 1. Okay, then you just combine your two fractions, simplify. Okay, now that I have this form here, since I have proved x squared minus 2x plus 5 is always more than 0 from part A. Okay, I can multiply this over. Okay, so before you simplify, don't cross multiply. Okay, simplify, bring everything over to one side, simplify as a single fraction, then you multiply over if you know it's always positive from part A. Okay, if you worked out that it's negative, you can multiply over as well. Just remember to flip the sign. Okay, so now that you have this inequality, okay, this expression means that this equation is always more than 0, right? That means always positive. So always positive, you apply the same rule again. Okay, b squared minus 4ac less than 0. Okay, then sub in your terms. Okay, and then solve for the inequality of k, like what we usually do. Okay, you end up with this final answer here. Okay.